We are going to begin our introduction to Chapter 6 by talking about how many children there are in your family. You have to include yourself. So if you have 3 brothers and sisters, your number of children in your family would be 4 because you got to include yourself in this. I'm going to move around the room, like just kind of asking as we move around, and I'm going to make tally marks. If there are more than 8 children in your family, and you want to include step siblings and half siblings. So everybody that's your parents or step parents' children would count as siblings here. If it's more than 8, we'll just add on to the end of the table. Not a problem. All right. So I'm going to start over here. How many children, including yourself? 5. Don't make the tally marks on your page because we're going to write down probabilities here. Boris. 3. Go back here. 3. 4. 4. 5. Sorry. 2. 4. 12. All right, so we're going to add a 12 over here. 3. Oh, sorry. 4. 9. Oh my goodness. 3. 4. 3. 1. Only child. 3. 2. 2. 4. 1. All right. So let's go through and write down our probabilities now. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 people in the room today. So what is the probability that we choose somebody at this class, from this class at random, and they have just 1 child in their family? 2 out of 21. We could write these as decimals, but I'm going to write them as fractions because that's way easier for what we're doing. That way I don't have to worry about any rounding. What's the probability that they have 2 children in their family? 3 out of 21. 3. 6 out of 21. 4. 6 out of 21. 5. 2 out of 21. 6. 0 out of 21. Or we could just write 0. Same thing as 0 out of 21. 7. 0 out of 21. 8. For 8. 0 out of 21. 9. 1 out of 21. Do I need to include the numbers that we didn't have up here between 9 and 12? Do you think we should include those? Yes, we should. So let's go ahead and add those in. So I need to include 10 and 11 here. Thank you. So for 10, what's our probability? 0 out of 21. For 11, 0 out of 21. And then 12 would be 1 out of 21. What does it say X means again? The number of children. If I wanted to be really specific, I would say the number of children in the families for students in this class, right? You have to always, 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 always define your variables. these probabilities together, what should it add up to? If I add all the probabilities, it should add to 21. Should add to 1. 21 out of 21 should add up to 1. So these guys right here adds to 1. Does it on ours? Let's find out. 2 plus 3, 5 plus 6, 11 plus 6 more, 17 plus 2, 19, 0, 0, 0, 0, 0, 20, 0, 0, 21. So we have 21 out of 21. We have everybody in the class accounted for. Is 5.7167 a possible value for x? No, because x means what again? Number of children. Why is that not a possible value for x? Can't have part of a kid. If you do, you get investigated. Can't have part of a child in your family. We call x a discrete random variable. X is a discrete random variable. We say it is discrete because it can only take on values that are countable numbers, whole numbers, with gaps in between those numbers. Like you can have one child in your family or 2, but you can't have 1.5. You could have 7 children in your family or 8, but you can't have 7.123, right? So we've got these gaps in between the numbers. That's what it means for it to be discrete. It's countable, and there's gaps between them. When I say it is a random variable, you guys have heard of variables before, right? Algebra 2, you solve for x. No clue what a variable is. I am so sorry. So when you're solving for x in algebra or algebra 2, usually how many values do you find for x? Usually just 1, right? Unless it's a parabola. And then you can find 2. When I say that x is a random variable, what I mean is that x can take on a lot of different values. And down underneath the different values that x can take on is where we put the probability that x is those different values. That's what I mean by random variable. Let's calculate and interpret this right here. What is the probability that x is greater than or equal to 3? What is the probability that x is greater than or equal to 3? Close. Greater than or equal to 3. 16 out of 21. Tell me how you got that. Yeah, we add from 3 all the way over until we get to the end. Or you could do what if you didn't want to add up all those numbers? Yeah, you could have done 1 minus and then the 2 that we're excluding. Now I want to interpret what that means. This 16 out of 21 is the probability that a randomly selected student from this class the probability that a randomly selected student from this class comes from a family with 3 or more children. Is 16 out of 21. So we're interpreting the entire thing here. We're interpreting the probability notation and the fraction. This right here is the probability that a randomly selected student from this class comes from a family with 3 or more children. Let's make a histogram of this. So what do we want on the x-axis for this histogram? Number of children. What should we put on the y-axis? The probability. So over here for my probabilities, they didn't fill in the y-axis. We need to go in and fill that in, but they did fill in the x-axis for numbers of children. What would be a good numerator to count by? I know everything is out of 21. Should we count by 2s? Should we count by 1s? You want to count by 3s? I'm trying to figure out whether we call this one 1 out of 21, or do we call this one 2 out of 21? Like, where are we going to start our index at? You okay if we count 1 out of 21 and then 2 out of 21 for the next line up? Let's see if that lets us fit all of our data here. There's 1 out of 21, 2 out of 21, 3 out of 21, 4 out of 21, 5 out of 21, 6 out of 21. Will that let me fit every piece of data up here? Yes, because the most we have, the highest probability from our table is what? 6 out of 21. We had 6 out of 21 here and here. We don't have any fractions that are bigger than that. All right, so we're going to make some bars here for our histogram. I'm going to need help from you guys because I don't see my table anymore when I'm on this screen. What was the probability that somebody has just 1 child in their family? 2 out of 21. So my bar is going to span on either side of the 1, and it's going to go up to the 2 out of 21. What's the probability that somebody has 2 children in their family? 3 out of 21. So we're going to go up a little bit higher here. 3 children? 6 out of 21. So it goes way up here. 4 children. 6 out of 21. So I need another bar that exact same height. 5. 2 out of 21. 6. 0. So do I need a bar there? 7. 0. 8 plus. So 8 or more. 2 out of 21. So there's our histogram. How would you describe that shape? Kind of looks skewed. Skewed which way? Which way is the tail? Tail is to the right. So we would say it is skewed to the right. And that works especially like when I'm thinking about it being skewed to the right. This one right here should actually be 2 little 1s off to the side. I don't have enough room on my paper to go out that far with the graph. So this is skewed right. Technically, we have a double peak because we have two values that are the highest, don't we? With a double peak at 3 and 4 children. So this was printed before I knew how many children there were in everybody's families, and my table only went out to 8, right? How do you find the average of something? Add them all together and divide by however many values you added together, right? So the table as originally written had 1, 2, 3, 4, 5, 6, 7, 8 on it, right? And that is 8 numbers, so divide by 8. That comes out to be 4.5. Does that work for this class? Would it work for me to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and divide that by 12? Would that find the average number of children in a family for people in this class? Also no. Why not? What'd you say? We're not counting for the repeating values, right? We had 6 people in the class that said there are 3 children in my family. We had 6 people in the class that said there are 4 children in my family. And then we also have some gaps too. Nobody said they had 6 kids in their family. Nobody said 7. Nobody said 8. Nobody said 10. Nobody said 11. So I shouldn't include those at all because we don't actually have kids there. All right, so my answer to question number 5 right here would be no. Because it doesn't account for repeats. Three and 4 should have the greatest impact. Because they occur the most. So here's how we account for those repeated values. This is where the probability part comes in. If we want to calculate the average, we take our x value. Where did the table start with our x values? What was the first x value on the table? 1. Why couldn't we have 0? Yeah, because you have to include yourself. That's why we didn't have 0 on the table. It wasn't how many siblings do you have, it's how many children are there. And you count as a child. So we take the x value and we multiply that by the probability that that occurred. What was our probability for one child in the family? 2 out of 21. Plus, and then we go over to our next x value, which was 2. What was the probability for 2 children in the family? 3 out of 21. Plus 3 children in the family? 6 out of 21. Plus 4 children in the family, which was also 6 out of 21. Plus 5 children in the family times, that one was 2 out of 21? I'm trusting you guys on this one because I don't have my table up. Plus 6 children in the family, which was 0 out of 21. 7 children in the family was also 0 out of 21. 8 children in the family, that one was also 0, right? 0 out of 21. Plus 9 times 1 out of 21. Plus 10 times 0 out of 21. I ran out of room on my single line, so now I'm going to have to drop down. Plus 11 times 0 out of 21. And then plus 12 times 1 out of 21. This right here would give me the average number of children for a randomly selected student in this class. This weights those different values. We would call this the sum of all of these things, the expected value. And the expected value, the formula for what we just did there, we would say mu of x is equal to, and then I have that sideways capital M. Do you guys remember what that means? Summation. It means we're going to add a bunch of stuff together here. The summation of every single one of my x values, so I call it xi, because that means x1, x2, x3, x4, x, all the x's, multiplied by the probability for each of those x values. So, could we do this by hand in your calculator? Is it going to take a hot minute? Is there a lot of possibilities that we make a mistake? Absolutely there is. I'm going to show you how to do this with technology, how to do it on the graphing calculators. If you have a graphing calculator with you, go ahead and pull it out. If not, grab one from the back of the room. What'd you say? The app does work for this, yes. So to get the calculator to give us the expected value, the average, we need to put our table into the lists. So I'm going to switch over to my calculator. Does anybody remember how to get to the lists? Close. You start by pushing stat, and then you want the option that says edit, which is the very first option. And you might already have some numbers in those lists. You probably do. To clear out the data that's already there, you have to go up so that you highlight the name of the list. You hit clear and enter, and it should erase everything in that list. And then if there's stuff over in L2, you need to arrow over, highlight the name of the list, highlight where it says L2, hit clear, and enter. And it should clear everything out. Does everybody have their lists cleared out? All right. So in list 1, we're going to put all the possible values for our random variable x. What was the smallest possible value for x? 1, all the way up to 12. So 1, 2, 3, 4. Make sure you hit enter after each entry. 5, 6, 7, 8, 9, 10, 11, 12. Definitely make sure you hit enter after the very last entry or else it won't put it on your list. And we want to make sure to include 12 on our list. In list 2, so now I'm going to arrow over. Too far. This is where we're going to put the probabilities. I'm going to type them in as fractions. The calculator will change them into decimals. That's okay. We can type in the fractions here. What was the probability for one child in the family? 2 out of 21. So 2 divided by 21, and then I'm going to hit enter. 2 children in the family? 3 out of 21. Hit enter. 3 children was 6, right? 6 out of 21. 6 out of 21. 4 children was 6 out of 21. 5 children. Was that the one that was 2 out of 21? 2 out of 21. 6 children? 0. You can do 0 out of 21, but it's just going to simplify that to 0. So you can just type in 0 for the ones where nobody had that many kids in their family. 0 for 7, 0 for 8. 1 out of 21 for 9 children in the family. 0 for 10. 0 for 11. And 1 out of 21 for 12 kids in the family. Hit enter after that last entry or else it will not put it on the list. So far, so good? All right, I want to make sure that everybody has all of that entered on the list before we go to the next step. We are now going to make the calculator calculate for us. So hit stat again. Do you see the option that says calc on the top? We're going to arrow over to where it says calc. We're choosing one variable statistics, so option number 1. And it's asking where our data is coming from. Oh, did it give like all the decimals? I think it's giving lots of decimal values there. Like if you put it in your calculator, since it's not a nice pretty decimal. Okay, so we're going to go here now. You're going to go to stat, one variable statistics. All right. If you're using the app, you have to type this in the parentheses separated by commas, but we want to tell it the list that we're using is L1, that's our X values. Then you arrow down here. If yours does not have anything here listed for the frequency list, we need to make it say L2. To make it say L2, you push second and the number 2, and it'll put L2 right there. Again, if you're using the app, you need L1, comma, L2. So second 1, comma, second 2. And then we're going to come down here to where it says calculate, and we're going to hit enter. Do you guys see right here where it has that summation of all of our X values? That's our mean. It took all the list of our X values and it multiplied it by the probabilities that we put in the second list, and then it added them all together. And then right here, you guys see the sigma and the X? That's the standard deviation. I'm going to jot this down. We're going to add this to your notes, but I will not remember these numbers once I'm off this screen. 3.857. And 2.455. All right, so back over. The mean, mu of x. This is the expected value or the average. we came up with an average of 3.857. And now I want to know what that means. This is the average. Number of children in a family after the long run of randomly choosing many students from this class that average is 3.857 children. Wait a second. Didn't you guys tell me before that 5.71 something was not a possible value for number of children in the family? Why am I allowed to get away with a decimal here? It's an average. I'm not saying that there are that many children in any of your families. I'm saying that that's the average number of children when we're looking at everyone's family in the classroom. So decimals are okay for my average. Our standard deviation, which we use sigma to represent. Yep, go ahead and laugh. We had 2.455 as our standard deviation. What does standard deviation describe again? Average distance from the mean. So I would say the number of children in a family from this class typically varies by about 2.455 children from the mean of 3.857 children. Sometimes you will be expected to show how you arrive at this number. It is okay to have the graphing calculator do the actual computation here. But it is not uncommon at all on the AP exam that you need to show work for how you're arriving at this number. And that's why I showed you guys this right here. When you put all of that in the calculator, you got 3.857. But you would need to show this multiplication. Then you can have the calculator do it by using the lists so that there's less chance for a mistake there. All right, let's flip this over. We're not going to get all the way through every single piece of this today. That's okay. I am going to ask you guys to finish up a little bit of it tonight as homework. And we'll go over that at the beginning of class tomorrow. Probability distributions look like this. We put all of our x values up on the top, all of the possible things that x could be, and we put the probabilities for those down underneath on the table. And those probabilities have to add up to 1. A discrete random variable takes a countable number of values with gaps in between. Again, I can have one child or 2 children in the family, but you can't have 1.4 children in the family. When we are describing a probability distribution, do you guys remember SOX? You guys remember talking about SOX? What does SOX stand for? Shape, outliers, center, spread. We want to describe the shape of our probability distribution. We practice doing that. The center is my mean or my expected value, and the variability is the standard deviation. We are going to start the Check Your Understanding together. You guys are going to finish up whatever we don't get through as homework tonight, so that then we can go over it at the beginning of class tomorrow. Home Alone. Have you guys ever heard of the Home Alone movies? Yes. Has anybody ever seen the Home Alone movies? Yes. Did you know there were 5 Home Alone movies? Yes. I did not either. I knew about 3 of them. There's 2 good ones. Not going to disagree. But there are 5 total movies in the Home Alone franchise here. Below is a probability distribution of the number of Home Alone movies watched by a very large sample of high school students. Let X equal the number of Home Alone movies watched. What's the problem with this probability distribution? I see one issue. It's missing this value here. Go ahead and calculate that for me. What number belongs there? .08. When I go to write the event, the student has seen exactly 3 Home Alone movies. Remember, when we write our probability notation, the event goes inside parentheses. So here's my event, the probability that a student has seen exactly 3 Home Alone movies. You said it came out to .08? How'd you find that? Yes, we added up all the numbers that were given there, and we minused it from 1. We got .08. But here's my probability notation. This is the probability that a randomly selected student has seen exactly 3 Home Alone movies. So what would this probability notation mean? Yes, the probability that a randomly selected student has seen one or more Home Alone movies. What would that probability be? 0.85. We do 1 minus the probability of none. What's missing on the histogram for number 3? The probability for 3, right? So we should fill that in. I know some people are still writing this down. We're going to get that filled in. We're going to describe the distribution, and you guys are going to do 4 and 5, or sorry, 5 and 6 as homework tonight. All right. So that should look like this. How would you describe the shape of that histogram? Skewed right. Any peaks? Where does it peak at? It peaks at 1. So it's skewed to the right with a single peak at 1 movie. I want you guys to do number 5 and 6 as homework tonight. We're going to compare your answers to mine first thing tomorrow when you come in. There's also some reading that I would like for you to complete so that you are prepared for class tomorrow. It's 13 pages, page 389 to 402. It's written on the board in the back if you need to snap a picture of it. Page 389 to page 402. The homework that you picked up on your way in the door is due on Wednesday this week. Homework is due on Wednesday.